Let us look at a few examples on solving exponential equations. So if you look at the first number here, number 1, which says 2 to the 2x times 2 to the x plus 1 equal to 1 to 8. The attempt is to get the same base on the left-hand side as on the right-hand side. And if we have the same base both sides, then the exponents will be equal. So let us see. We can use the sum rule for multiplication, and the left-hand side we can simplify that by writing 2 to the 2x plus x plus 1. On the right-hand side, we need to find what is 128 written as 2 to the something. We know 2 to the 4 is 16, and 2 to the 5 is 32, and if we continue finding the value, we will see that 2 to the 7 is equal to 128. Now we have our base on the left-hand side, on the right-hand side we have that equal. So now we can conclude that the exponents, which we can add now, 3x plus 1, if we simplify here, will be equal to 7. If we now solve this linear equation, we get 3x equal to 6, and that will give us x equal to 2. We can test our answer by substituting this value 2 into the original equation and see if we get x equal to 2. We will have, if we put x equal to 2 into the left-hand side there, we will get 2 to the power of 4 times 2 to the power of 3, and that will give us 2 to the power of 7, which is the same as the right-hand side. Whenever you solve equations, you must always test your answer. Let us look at the next one. Here we have, on the left-hand side, we have 3 to the power of x minus 2. So our attempt will be on the right-hand side to find 3 to the something. In this case, 3 to the 3 is the same as 27. So again, our base here and the base there is exactly the same. Both of them are 3. So we can conclude that the exponents are the same. In this case, we have x equal to 5, solving a normal linear equation. Again, if we put the 5 in there, we get 5 minus 2, which is equal to 3, which will satisfy the right-hand side. Let us look at the next example where we have something, in this case 7 times 3 to the x minus 2. We first have to get rid of the 7 there, and the way we get rid of it is just like we did before. We divide both sides by 7, so then we get 3 to the x minus 2 is equal to 243. You can check that. If I now write the 243 in terms of I want the same base, I want the 3 on that side. So if I have 3 to the x minus 2 equal to 3 to the, I will find that will be the value of 5. If I play around a little bit, remember we have 3 squared is 9, and another 3 squared is 9. 9 times 9 is 81. If I multiply 81 again with 3, I get 3 to the 5, which is 243. So in this case, I have x minus 2 equal to 5, because I have this again here. And now we can conclude that our answer is 7. We can check again by substituting 7 into our original equation, and you get 3 to the power of 5. When we simplify, multiply by 7, which will give us the number 1701. Let us look at the next example, in which case we see we have a 4 to the something and another 4 to the something and just a regular number here. We can group the 4 to the power of something on the left hand side and take the 240 to the right hand side. But let us factorize the first two terms here. So let us take out a 4 to the x. Then we have 4 to the 1 left for our first term, minus 4 to the minus 1 for our second term. And we take the 240 to the right hand side, in which case we have 4 to the x, and in this case 4 minus a quarter. If we simplify this, we get 4 to the x, and we have 16 minus 1 over 4, which is 15 over 4. So I divide by 15 over 4, or I multiply by 4 over 15 both sides. And then I simplify my right hand side. And if I simplify it, I see that 5 goes in here. 3 times 5 goes into 24. 4 times in 48. And if we look at 3 again, we can say 3 goes into 4, 8, 1, 6 times. So we have 16 times 4, that gives us 4 to the 3. So we have 4 to the x equal to 4 to the 3. That means x is just simply 3. Again, you can test your answer by substituting it back into our left-hand side here. And then our right-hand side just remains 0, so we must have, it must satisfy the equation before it is a solution.